Hello everyone and welcome into yet another live stream. No point in much of an intro today because we mainly just need to finish the video. Yeah, I didn't actually manage to finish it yesterday. I tried. I did try, and I did fail. However, today, I recorded almost everything. There is still a little tiny itsy bitsy bit of a script left to finish. However, I did. My taskbar isn't working on either of the displays. That's great. I did record almost everything. Other than the part of the script that I still need to script. Obviously, that I wasn't able to record because there was nothing there. I recorded everything, and this is how far I am so far with the editing. So, splendid. Okay, hold on. I need to do the sound effects first for this. There's a bit of an echo in this, which I have no clue why that is. I know you can't hear it, but I can. And I have no idea why this bit of audio has echo. Just haven't got the slightest clue. Okay, cut this, cut that, put this here, this here. In the background, I'm still rendering the animations, because of course I am. We're going very minute per frame, goodness gracious me. Oh no, I have two different panes open, I should probably off. What else do I have open? The background I can turn off. I have a notepad I can turn off. This I can turn off. Not much else. Terminal I can turn off. Task manager. Yeah, about it. Oh, I just realized I didn't apply any modifiers to that. Oh, damn it! How far back did I not apply them? And then clear audio type dialogue. Turn this off, and then podcast voice. Once. Yeah. Right here, I need the music to get back again. Yeah, I'm not gonna be all that much entertaining today, mainly because well, I'm trying to focus up on the job at hand. Basically, this the total so far seems to be around-ish of 24 minutes, and we are on minute 14, which means 10 minutes high above high, which means 10 more minutes. No, 5 more minutes, obviously, but like, 10 more minutes of, of the stuff I need to edit. Then I need to finish the script, then I need to record, and I need to do everything, and then it's gonna be great.
5 more minutes twice.
Exactly. And this is already part 2.
Hi, Bob.
Hi there, Alex. How you doing? Hi there, Shay. Hey, Mickey. How have you been? Sorry, not like the shit's messed up here due to rains because of power cuts. Right up to date. Not much, just trying to finish the video I've been struggling to finish for a really long time. So, it's the usual.
The classic make it pipeline.
I do think I got radicalized by J-Rush for the first time. I've, like, yeah, I think I've gotten radicalized finally. Finally got
What
to
do you
me.
mean?
Well, I really don't like clunkers.
Have you seen the video?
I have seen the video, yeah. I don't like the clunker should be in the league of its own. It's beautiful. Hi there, unholy fingerable. Hi and welcome. Ah, okay. Okay, there we go. You can see just how messed up it is to the lack of samples, but I couldn't do more samples because, like, well, my render times are struggling already.
Mm-hmm.
Oh, I remember we discussed CNC machines, camera plus calibration during a stream. You're also considering, I think you can still DIY with OpenCV. What is OpenCV? OpenCV. Oh, that's OpenCV.
OpenCV.
Vision clunker.
Mm.
I don't mean to be that guy, but those are some really deep fried images. Those images are severely deep fried.
Oh god, you can see that.
Yeah, I mean it happens because I have my dark reader on. Like if
It's
I
just
turn it
dark
off.
mode thing though.
Well, no, it's not dark mode thing. It's just that dark mode is what reveals it. Like dark
Oh
mode
yeah.
isn't putting its own images. It just changes it like
Oh yeah,
reverses the
cause
colors
yeah,
basically.
it's like transparency with like some fucking fluff on it. I see.
How much did you sleep? I don't know. I don't like looking at my clock. Ah. Oh, all of my.
You have a very nice clock.
I don't even have a clock. I'm clockless.
No clock. Damn.
So close. Once again, sorry, I'm just sitting here silent, but I'm slightly exhausted and there's still so much for me to do. Ah,
It's fine, man.
personally concerned, I think you can still DIY with OpenCV. Wait. DIY what? Since camera plus calibration during a stream. DIY what? I remember the CNC machines discussion. I have a CNC machine now. I don't remember what the OpenCV would be for. We were looking for cameras for CNC machines, and the camera with software just costs like 1200. What cameras for CNC machine? I don't remember that. We were looking at CNC machines, that is true, and I got a CNC machine. I don't remember cameras for CNC machines. I don't remember that conversation. What would the camera for a CNC machine? I mean, for time lapses? That sort of thing? No, man, I need more coffee. Hold on. Okay, I'm waking up. I'm slowly waking up. 16 minutes, something. Okay, how's the animation going? Make it, I'm going on vacation and from there I cannot watch your lives. Is this fine? Obviously it's fine. It's okay, it's gonna be a lot of live stream when you come back, don't worry. Cameras for precision, alignment, and automation. I don't think CNC machines are precise because of cameras. Like, they don't do precise things because of cameras. I don't even think CNC machines have cameras. They can do precise movements because they have. I'm pretty sure it's called stepper motor, isn't it? That's the type of the motor. It's already going in a tangent. Stepper motor.
Probably.
Yeah, they're driven by stepper motors, which makes the movements precise, and you can control on each of the three axes how far it goes, and that's what gives them the precision. Cameras would be a very roundabout way of achieving that. There we go, this. Okay, these are absolutely all of the animations I have.
Mm-hmm.
Oh, this is way less than I was hoping for, actually, because this is it so far. This is all of the animations. And I still got this segment, plus a little segment at the front that I still haven't recorded. Plus the intro, but that's easy, because that would just be the whole, like, flying. Oh, you'll see. Okay, the point is, this one takes a minute per frame, which means we might want to... Well, reducing samples would be nice, but unfortunately, instead of reducing samples, I feel like a much better way to go about this would be to increase the brightness, because in Blender, when you are going with like the threshold, that's one of the newer features in the threshold thing, where basically if you have more stuff that's brighter, then you can then that may lower the threshold needed for render, which means the renders are just quicker because there's less rendering to be done. But in order to do that, we need to somehow make something brighter without absolutely ruining the continuity of this scene, which I'm certain we'll figure it out, alright. For now I need to go over all of this and just add in, like, extend all of them. Bridge the gaps. Because so far we're at 9 minutes. Boink.
9 more minutes.
Hide the thefter. Enter the use of the camera at the end. Well, yeah, but there would, well, I mean, I would just add some kind of bright object, but the problem is that they would ruin continuity because I'm starting with a dark scene. Throughout the entire video, you can see it's dark background with glowing objects, and so if I all of a sudden make something brighter, then that would just make this really out of place. Hide the phone, man. $25 you can do it, make it. I really want to go to the. I really want to go to the hardware store today, and it closes in 6 hours. So I'm not saying we're under a bit of a time pressure, but you know, July 8th live stream. Oh, you're gonna make me look back on it now. I was just talking about time pressure, and I'm already going off the rails. Just should I learn C or Rust? Obviously C. C is better. Did you ever get your printer? Nope. Nope. The delivery company, DHL, should I mention, shipped it off to Germany because they kind of. Well, they said that they failed to not failed to deliver, only that I failed to pick up. So without calling me or without, you know, trying to deliver it, they just sent it back and told me that I declined the delivery. My 10. This is the July 8th live stream. And we were looking at CNC machines later on, I do believe. Okay, no. 882. C used to annoy computer science majors before they used Python. How dare you, sir, insult my C? Only I can insult my C. What is C used for? Every single other programming language in existence. Well, that's not exactly true. Every single mainstream programming language in existence can trace back its roots to C. And also most, like, you know, most operating systems, most integrated systems, 90% of technology and such. It can do anything. The only problem is that it takes a lot of time really often to do everything. When were we looking at CNC machines? It wasn't 8, it was 884. Is that also July 8th? That's also July 8th. Not included. That's not it either. Oh my goodness, I'm just going over all this thing different. Didn't want to name it, and they had A, B's, they just named it C. Yeah. That's okay, that was the gay lab.
The gay lab?
Oh, that was from the last video. Splendid. No, that's still showing, but it's still not it. 882. Okay, so 1 maybe then. I'm really glad, Abhishek, that you told me the stream by date instead of. If only we had some kind of indexing system for the live streams that we could go up to. If only we had like. If only they had like an identifier, like, you know, like a unique number that that sorts them. Okay, no, this is SolidWorks documentation. Oh, I had so much fun back then. I wasn't working on video, I was working on fun stuff. Still, none of it. 881, maybe 880.
That's not the way to look at that.
That must make it, okay. Do you want to stream of twins? 893. 93? 893?
$93.
That is not July 8th, that's 18th!
Wow.
That is not July 8th!
Not only he tells you that he is wrong.
Oh
With
my,
it.
hold on, I need to find the...
What a man.
Acid animations. I like how when you scroll over it real quick, it goes frame by frame, rendering the background with the animation. Drunk Make
Nice.
It, obviously. Water.
Drunk make it. Isn't that just make it?
It is. Yeah, so this is just... I'm pretty certain we finished up with... Oh, that's when I ordered Danny, by the way. I still don't have it. I just...
Man.
There we go. Yeah, we were looking at CNC machines, but I mean... Yeah, we were looking at... I don't know where the cameras came. I don't... Fucking detail. I agree. You know, just, you know... Scary Make It Industries. Lost media. I like how we,
I mean, at
we
this
got
point, yeah, pretty much.
$1,000. That's nice. Good for charity. I don't know what the context cameras were because I don't remember talking about CNC cameras because I genuinely don't think that CNC machines have cameras in them.
Do they? Okay. Why not?
Well, why yes? That's kind of like saying, that's kind of like as if I said, I don't think bicycles have cameras in them, and you ask me why not, what kind of answer
Why
am I
not?
supposed to give you?
Let them have their dreams.
Let this rotated lumetry. Yeah, you can just DIY the camera by buying lenses, then use a motor to move the camera, and you said calibration is an issue. Wait, what? Camera on a CNC? That is even weirder.
I mean, for calibration, it would help, probably. You know? I'm sure there are reasons to have cameras there.
You're describing it as if we were talking about the camera on the CNC, as in the CNC moving the camera. But that is even
no.
less likely because...
Not on the CNC, like, as part of the fucking rig, you know?
Well, if you have motors moving the camera, that's kind of camera mounted on the CNC. CNC moving the camera. Have you tried using a camera? Well, I've used cameras once or twice before.
I know, have you?
It doesn't make sense for a camera to be mounted on a CNC. Because I don't see what the usage would be. I am terrible at letting things go. I have a very obsessive personality.
Don't you say?
we're at 10 minutes 50. So far, we're moving crazy quick on this stream, but that's because I already have everything ready. So that's the reason. Once we reach the end, then we're going to run out the animations, and once we run out the animations, then it's gonna really slow down, because not only will I have to, before editing, not only will I have to make the animations, not only will I have to animate them, not only will I have to render them, I will then only begin the editing process. So,
well, I think the other things while you were in there, like eat hot chip and lie. You know humor, don't you?
no idea what you're saying.
Whatever. I will not repeat it even once. You disgraceful fuck.
Okay, right here. Also, this is finished rendering. I need to render the rest of them. 6 this to 60, like so. There we go. Now we could, I don't know if lowering the samples is a great idea. I honestly am not the biggest fan of the idea. What I can do, however, is I can very slowly... No, I can't raise the brightness. Oh, damn it. I can't raise the brightness of text. I can just hope that as I go down... The problem is that the material there is a volume in a glass shell, which is basically as terrible to render as it gets. I'll be challenged to come up with something that's more difficult to render. So... Oh, shit. Yup, and then you obviously need to do the line.
We love transparency. We love transparency.
Okay, right here we need channel, and then playlist, and then quantum mechanics. Shut up, must make it. There we go. Quantum mechanics. I only have 4 videos. To be fair, those 4 videos are pretty dense, I would say. So I'll do a pass.
Are you intentionally dense? Meow.
Oh shit. And right here, ideally also, I would like one of the videos, which I did use previously right here. There we go. Now, which one discussed the normalization? I think this one, because this one goes, yeah, I mean, yeah, that would be the most accurate one, I'd say. Since we need to shrink this, and get back in here. In. Go, rotate, scale down. Oh, this goes this way too big at the end. It needs to be smaller. A 6-minute begun. No. We're still 5 minutes, okay? That's all I need. Trust me. Trust me, I just need 5 more minutes tops, and then we're gonna be finished.
5 more minutes, bottoms.
Oh, that's maybe you. We're going like crazy. 12 minutes. So far the entire audio recording is 25, so this is not bad. Okay, splendid. Here we go, we're on 12 minutes. Going like crazy, going like crazy so far. Do you know every day 1 minute happens on making?
True. Wise words.
Okay. That's it. I really miss making stuff already. I need to fix up my 3D printer because I will probably fix it up quicker than the new one will fucking come. I don't know what that. I need to like message them. Oh, that's something I also need to do today. Shit. I need to message Bamboo Lab, letting them know that my printer went back to them.
Classic.
Make it as the god of poverty. Ouch.
Words can be hurtful. You shouldn't say those things.
Chaos god of poverty.
Damn.
The Primordial 5.
And poverty.
Okay, splendid. Once. 14 minutes. See, I told you we're moving like crazy. Well, for now, as I mentioned, once we reach this point, it's all gonna grind to a halt and I'm gonna have to find something completely different. I imagine the script. The part of the script that I got stuck on is the... right here. Open. No, let's keep this, yeah. Which is rotational molecules I will not get into, now this would be too long for this video. It is the bonding, anti-bonding. Yes, and the only thing left for me to mention, I do believe, are why valence shells matter, and then like a bit of a revision which will put into perspective why like general chemistry rules happen. Maker's demons include flame, the briber of Make It. He takes money from material to immaterial, where Make It through Paper's Dark Age of tech 3D printer repair.
Literally.
I am committing of tech heresy, but that's the side hustle. Ah. Okay. Okay. How's the render? Is it speeding up? No, still at 57, so it is absolutely not speeding up. That's to be expected, kind of, and I should probably shorten them from 30 frames to 20 frames. That would make this a bit quicker as a render. I mean, I started playing on my butterfly knife, getting some working. If I had that nickel. Okay. Back to it, naked, back to it. You're not getting paid for slacking about. Well, you're not really getting paid in general, but not important right now. You're getting paid? No. No. Okay, right here I'm going to need some make it reaction images. Which I should probably make for this. I shouldn't reuse them. This doesn't make any sense. How can I...
You need more reaction images.
Where's my make it's folder? My beloved intents. There you are. Give me you. And that's what I'm gonna recycle. Now, right here. Make it, I believe is what I always called it. And then the usual. 80. 20. Whoops. No, I meant. There we go. I gotta go. I gotta get some shit done. Bye, Abhishek. Bye. Have a good one.
What?
Okay. Reset all of these. Delete the keyframes. Reset all of these. Delete the keyframes. Now for the poses we will need. Oh no, I need to play some. Why am I so sleepy and tired and everything? I need to wake up. This is dangerous.
Wake up. Go, boy, wake up.
Okay. I need to pour some water in my face. Okay. Wow. Alright. Alright. There is a job to be done. The hardware store is closing in a 6 hour. I can't do math. 5. I have like 5 hours. The point is, alright? Start the clock and let's get to it. In the meantime, while this is rendering, actually, what I'm going to do is I am probably going to finish the script, because if I finish the script, then we can fully record everything. And if we fully record everything, then we can actually see the maximum time required in order for us to finish it all. So what I'm going to add here is add segment. I'm going to add here is the intro, and now all we need to do is we need to script the end of the video, script the ad segment, script the intro, then we're done. Then I'm gonna have to record them all, then we will have the specific time set for the maximum, and then we can check the ratio of how quickly we're going. We can also check how much time it's going to take us. We can make estimates, and 5 hours, actually less than 5 hours, it should be like 4. Damn it, I'm not going to make it the hardest, or am I? Well, trying, setting too high of a bar for myself and then failing is sort of my thing, so I'm all for it. I need like, hold on, online timer, I suppose. 5 hours, that will make this 8, that would be barely, yes, we can need like 4. Four hours, 0 minutes, done, start.
Okay.
There we go. Now I'm gonna add it. This on my timer. Just to add, you know, a bit the stakes of the stream. Just like, just to add a little bit of a pressure. You know?
Yeah, a little spice, you know.
Exactly, spice it up a bit. What are you going to onto? Which this time requires more energy, and from there it doesn't matter. If you think of it as energy loss, being offset energy. So that is why hydrogen bonds and helium doesn't. What's more, this also explains why only valence electrons matter. That's because if you think about it, all of the electrons lower down in the bonding down are full enough so that one of their electrons will go to the bonding orbital and the other to the anti-bonding, cancelling everything out. And that's why noble gases. Still messing up. Proceed to spend 10 seconds every cropping in a time when there's actually cancer. Shush! Average blue! Shush! Shush! Okay? Don't question me. I have a plan. Alright? I have a plan and we're gonna succeed.
Your plan.
We have 3 hours, 58 minutes, and only a little bit more of a video to finish, okay? It's fine. On plans, and that's why noble gases. So, in that, the electrons themselves with the anti-bonding orbitals, and oh my, we the end. That's because right now you can understand the not only you can you not only know what the rules of chemistry are, but also why they happen. For example, ionic bonding is when two opposite charges attract like a magnet. This doesn't require any quantum mechanics because, well, it's just basic physics, but understanding the difference between ionic and covalent does. And so if you've been confused in the past how neutral atoms with no net charge can stick together without using charge, then this is how, using quantum mechanics. Chemistry and quantum mechanics, not except for the zero. Thank you, Munch. I'm good. I'm really close to finishing it. Give me like 5 more minutes tops. Why did the timer stop? Oh, it didn't. I just have to refresh it. Okay. So I can't have it completely in the background. Okay. Oh. There's so much more I could mention. Rotations of others. I feel like I'm gonna end this video differently. Instead of going for the drawn out ending of the old ad save and everything, I'm just gonna like end it. That's it. There's conjugated systems. What was the name of the thing in benzene? The thing that happened between the thing that had such a shitty name.
Thing with shitty name, famously known as.
Where is it? Structure. You'll know what I mean, right? Alright, Caper, bye, have a good one. I just need 5 more minutes, trust me. I just need 5 more minutes tops. What was the name of Resonance? Oh, was it Resonance? I think it was Resonance.
Resonance.
Yeah, I think it was Resonance. Resonance, metallic bonding, but yeah, and then I'm just gonna end it there. Cut to black screen and end the video. That's it. I really like it when YouTubers do that, because then, well, the video ends right when it ends, and just nice. You just watch it to the very end. I have skull and screw right now. Resonance. Well, unfortunately, I won't touch on resonance in this video. Well, you could like get the quantum mechanics I've explained, and you could figure out why resonance happens based on it. But unfortunately, I don't have the time to explain it. Add segment. Hold on. Thick coins. Theodore Nichols. It was Theodore Nichols, not Theodore Nicholson, right? Because I always.
Yeah.
Yeah. How did you spell that though?
Theodore Nichols.
It must be trust. The
mint.
Theodore Nichols. Okay, there we go. Theodore Nichols. Thick Nichols.
Legendary fucking bit.
Have you ever looked at your Nichols before? And
It needs to be perfect. Just as fucking Theodore Nichols.
He's a very generous man.
Yeah, I used to say that. And I stand by it.
That's then. Well, Nichols got covered with the groundbreaking nickel manufacturing. They can codes real quick and You got Nichols on ship? No, I didn't. That was just a bit for a video. I can't even afford a nickel. I don't have enough money for a nickel.
Damn.
It's a good bit. Thank you, Bunch. I know, I am hilarious.
There's always enough money for a nickel.
No, unfortunately, I do need to mention the real thing, which is the Patreon, because I am struggling financially, guys. Not. I'm feeling good at least because the insurance company I got, they decided to pay out insurance for to the my landlord from the past flat, which means I'm gonna be getting the full safety deposit back, which is nice. So in a couple of days I'm gonna get. I was doing Discovered and they go, I remember much, yeah. Well, Discovered, Quasar, basically told me about it. 3D printers aren't cheap. Yeah, so aren't oscilloscopes or CNC machines, I know. Hey, listen, I'm not blaming like economy or state of matter for me struggling financially. I know the reason, okay? It's not a mystery. And sponsored by my patrons. And so hi there's gaming, hi. This number was like 200, it was like 300. Okay. 4 more frames, so 4 more minutes, then this is gonna be finished. So far we're 12 minutes down already. It's not great. It's not doing amazing, but it could be worse. No, it's enough showing.
You say so?
There we go. And then the intro will be. That's how. Chemistry is like this. Valence, electrons, valence, white bonds are covalent, and bonds just fine, but helium struggles. Well, I'll explain all of that in this. There we go, that's all of it. Now all I need to do is just record. That's it. And then... how does that say we're making? I know, I'm hilarious person. Where did I finish off? Anyone? No, you don't remember, I did it off camera. Where did I finish off the recording? Shut up, must make it! Still so much left. Oh, why is this such an utter and supreme shite? Should be button for the thing. The type dialogue. Okay. Now all I need to do is just record, right? Yup. me. Let's mute this. Let's record. The place where I finished off recording was right for hybridization. There we go. Because what oh shit, no, hold on, I can't record like this. Because I'm looking sideways at my screen, I need to look at the... Because what happens when two orbitals combine? So basically we have the s orbital with one electron, which looks like this, a p orbital with one electron, which looks like this, and actually let's add an additional two p orbitals just to make this simpler. Now we have one s orbital and three p orbitals. Chemists, please don't mind the viability of this, I'm trying to make a point here. Now let's say, as something that's definitely not a foreshadowing, that's outside of our atom, we'd have 4 points. These points would attract the electrons. These points would attract the electrons. Then what would happen is our orbitals would try to fit and stretch and reach these points, and it would turn all of them from a single s orbital and 3 p orbitals into a hybridized sp3 orbital. And so here's where we reach another important point. Orbitals can merge. The main rule describing this is that every time they merge, the amount of orbitals going in has to be equal to the amount of orbitals going out. So in our hybridization example, first of all, there'll be only 2 p orbitals and a single one s orbital with 2 electrons. But more importantly, there will be effectively 4 sp3 orbitals. That's each one of these legs, and the way they happen is we just take our underlying wave functions and we just combine them. So these are the wave functions for the underlying s and p orbitals, and these are new hybridized orbitals. You can think about it in one dimension kind of like this. We have our function which describes the probability of us finding the electron in the s orbital and the probability of us finding the electron in the p orbital. Then if those two orbitals hybridize, then what we get is the new sp orbitals, and as such these are the new probabilities of us finding the electron. And so that's what hybridization is. But why would that matter? Pun intended, get it? Why would that matter? It's fun, we're talking about... You get it. 4 sp3.
Well,
Did I say
all matter?
Did I say 4 sp3? I thought I said like 4 sp3 as in for that thing. I don't think you can... Wait, no, 4 sp3 as fourth shell. Alright, whatever. Hi there, Artistic. Hi, welcome. Okay, so that was hybridization. Once again, I'm having trouble breathing. That sort of thing just happens with age, you know? Also, in the meantime, when I was recording this, I realized that this thing finished rendering, which means we can change this to be...
You have to like open your window sometimes, you know?
I can't open my window right now because it's too loud.
Oxygen, you know?
The render animation.
Hmm.
Here we go. Oh, and just... it sucks for recording when I can't breathe, but happens. You can record and open the timeline. Yeah, but I can first record and then turn it.
You know, sound like a bit, you know? Probably help.
Well, it would matter because of bonding. So basically, we have two atoms, hydrogen atoms to be more exact, both of them with a single electron on the s orbital. As we bring them closer and closer, they merge together, and as such give us two new possibilities for their shape, the sigma and the anti-bonding sigma. What are those two new orbitals? Well, there are two ways you can understand them, the quantum mechanical way and the chemical way. First, we'll start the quantum mechanical way, which means treating our electrons as wave functions. And for that, we'll go back to particles in 2 dimensions, where this is what the 1s would look like, and we've got 2 of them. And the first one... The first one belonging to the first one belongs to the first hydrogen, and the second one belongs to the second one. Now when we bond both them together, this is just the equivalent of us adding both these functions together. The important thing here is that our functions are complex, so they are both imaginary and real. And the crucial part is that we add them, and then we do the thing to get the probability, not the other way around. And the reason why this is important is because if we add both of these functions like this, then fucking hell, what's wrong with me? And as you can... shit. And the reason why this is important is because if we add both of these functions like this, then this is what we get. Simple. As you can see, we get a larger probability in the middle. That is the bond. The electrons basically both pull the hydrogens to a point between them, shrimpo as it could be. But, just as a hypothetical, what if, instead of adding our wave functions, we subtract them? This would be equivalent to the wave functions having just opposite sign. And if we follow the equations, we can see that what we actually get is a wave function like this. That's because even though we get a positive number from squaring and such, we subtract them before we square. And you can see that this results in the wave function having a wedge in the middle, and the electrons more like pushing each other away. So, just as a quick recap, if we merge two orbitals together, we get this function if they are not the same sign. So, to recap, if we merge two orbitals together, we get this function if they are the same sign, and this function if they are not. Now, which one of them is our sigma orbital? Well, both of them. This one is the bonding sigma orbital. This one is the anti-bonding sigma orbital. And so if we go back from quantum land to chemistry land, then you can see that whilst our bonding orbital is lower in energy than our s orbitals, the anti-bonding one is higher. Which is why when two hydrogens come together, both of the electrons drop onto the bonding orbital. The shape of the orbital brings them closer together, which is why they stick and don't drift apart. And the lower energy of the bonding orbital is what keeps them that way. That's because in order to break the bond, you need to add energy to the system. Hence why the bonds are stable. And so that's why you won't really find any hydrogen atoms on their own, and instead you will always find them as hydrogen gas. They are just that much more stable like this than like this. But what about if we add more electrons? Well, due to how each orbital can only house 2 electrons, if our atoms don't start with 1 electron each, only 2, then they first fill the bonding orbital with 2 electrons, and then that's it. Our other 2 electrons can't fit anymore. So where do they go? Let me just pause to read the chart a bit. Sigma and the anti-sigma. You need to drink water and not go insane by the amount of reading errors. I'm already going insane by the amount of reading errors. The thing is, I used the script more as like a general guideline of where I'm supposed to go with it. Because, we know, it's easier to speak than read. Well, they go to the only other option, that is the anti-bonding orbital, which this time requires more energy. And from there, it doesn't really matter if you think of it as energy lost being offset by energy that has to be gained, or the anti-bonding orbital repelling the atoms, offsetting the bonding orbital pulling them together, or as the wave function being less desirable because of the electrons appearing more in the atoms separately, because all of these models result in the same thing. Atoms not bonding. And so that is why hydrogen bonds and helium doesn't. What's more, this also explains why only valence electrons matter. That's because if you think about it, all of the electrons lower down are full enough so that one of their electrons will go to the bonding orbital and the other one will go to the anti-bonding, cancelling everything out. And so that's why only valence electrons matter. That's why noble gases are so inert. Their electrons offset themselves with the anti-bonding orbitals. And oh my, we finally reached the end. That's because right now you not only know That's because right now you not only know what the rules of chemistry are, but also why they happen. For example, ionic bonding is when two opposite charges attract, like a magnet. This doesn't require any quantum mechanics because, well, I mean, it's basic physics, it's just like a magnet. But understanding the difference between ionic and covalent does. And so, if you've been confused in the past how neutral atoms with no net charge can stick together without using charge, then this is how. They do it using quantum mechanics. And there is so much more I could mention, like the rotations of atoms, conjugated systems, resonance, metallic bonding, but it's already been 2 weeks since my last video, so unfortunately I don't have any more time. And that's genuinely how I'm gonna end the video, no like ending segment or anything, because... Well, anyway, this appears to be all of the recording so far. There are only 2 additional tiny segments, which is the intro, which we'll need to render Rust, and then reading errors and anti-reading errors. Why do opposite charges attract? There is no answer for that. Funny enough, that is actually a phenomenal question, because the answer to it is that there is no answer. Like, our physics models electromagnetism as an fundamental interaction, and particles are elementary particles when this interacts. So opposite charges just attract. Like, there is no underlying explanation, because the interaction is fundamental and the particles are elementary. By definition, there is no underlying explanation. But it's a really good question. Because you wouldn't think about it, right? I remember a while back ago that's what launched me into the spin rabbit hole, because, well, with spin you also don't have any underlying explanation for why spin happens or like what it is, because it happens to an elementary particle. So you just need to kind of accept that it does exist. Okay, 2 final segments. One of them being ad segment, where I thank my beloved patrons, and the last one being the intro segment, which will be really short because it's just the intro. Theodore Nichols! Theodore Nichols, thick nickels. Oh shit, I need to read this properly. Hold on. Theodore Nichols, thick nickels. Have you ever looked at your nickels before and thought, that's awfully thin? Well, Nichols got you covered. With their groundbreaking nickel manufacturing technology, they can thick up these coins real quick. And who am I kidding? I'm not actually sponsored by Nichols. I can't even afford a nickel. But who I am sponsored by are my Patreons, and so I just wanted to take a second to thank you all for allowing me to continue making my videos, my projects, and even allowing me to get a 3D printer. Not this one, that is Jesse. Jesse is in a coma. This one is broken, I'm trying to fix it. I'm in the process of fixing it. The actual 3D printer I've ordered 2 weeks ago still hasn't arrived because a certain delivery company decided to bring it to the city where I live and then ship it back to another fucking country. Like, that's good. I'm a phenomenal actor, aren't I? I know. But anyway, the masks, the weapons, the chemicals, the videos, all of that I can only make because of my patrons, so thank you all so much. Anyway, that is the ad segment. I am just really starved for some good making. I'm really upset over the whole printer debacle because it stops me from making stuff, and I got that itch that I just cannot scratch. I need to make something. I have no mouth, yet I might scream. I need to make something, but my printer is in fucking Germany. We've all been there, let's be honest. Alright, one last segment. Intro, that's a quick one. Have you ever wondered why chemists... Shit. I already fucked up. Have you ever wondered why chemistry is the way it is? You know, why valence electrons are valence, why covalent bonds are covalent, and why hydrogen bonds just... Have you ever wondered why chemistry is the way it is? You know, why valence electrons are valence, why covalent bonds are covalent, and why hydrogen bonds just fine, but helium struggles? Well, I'll explain all of that and so much more in today's video, where we'll go from basic mathematics through quantum mechanics up to chemistry. But first... There. Okay, that's good. That is good. Because Wouldn't you want to figure out what charges actually are to figure out why they interact? Well, no, they are elementary and fundamental. You cannot, like, by definition, there is no explanation. That's kind of like, you know, it would be kind of like trying to figure out why 1 is equal to 1. You define 1 as being equal to 1. And the reason why, like, what are charges is just charges. I know I'm going very circular about this, but we define them as fundamental and elementary. So they are fundamental and elementary according to our models. Now we can obviously have another model which models them as something different, but well, I imagine then it depends on what model you're using. So there isn't really a satisfying answer, because if you're using another model, then charges could not even exist. Okay, there we go. This is fine. So far, right now, what's really nice about this is that we can actually check the progress we're making. Okay, so imaginary numbers, which I've done like times at this point. Alright, splendid. So we have 3 hours and 30 minutes left. Easy. I mean, let's be not even gonna be a challenge, isn't it? It's come on, 3.5 hours. Trivial, truly trivial. And so far we have 14 minutes done, and it appears that the entire voice recording is 35. So we're like less than halfway done. Good. Good stuff. But as I mentioned, as long as we have the animations, it will go real quick. I can explain this. This smaller, rotate. This is right here. This should be cut like so. Beautiful. First, this right here, I'm doing a list. I know you can't hear it because I've disabled my desktop audio. It's a bit too copyrighty for the stream. Half an hour, come on, make it. I should in the meantime also keep track of my average speed of the video making to see how quickly we're going about this. Okay. There is a bit of an... Hold on, let me switch to my desktop sound. There we go.
End up with it on the other side. To yourself, make it. This doesn't make any sense. How can our...
There's a little bit of an echo in there, but I don't know why.
Particle move through an impassable barrier. This would be any sense. How can our particle move through an impassable barrier? This would be teleportation. You must have gotten it wrong. Make it. This doesn't make any sense. How can our particle move through an impassable...
Why is there an echo?
This would be teleportation. You...
I definitely know that there wasn't an echo when I recorded it because, well, I was there.
To move through an impassable barrier. This would be teleportation. You must have gotten it wrong.
Bother me a lot.
Wrong. To yourself, make it. This doesn't make any sense. How can our particle move through an impassable barrier? This would be...
Okay, now what we need is we need the 3D makers to be proper and animated and lively. So let's... Hold on. Go. these, absolutely unnecessary. And now, and now, and now. Why do I have 4 makers in there? Where are the other ones? So these are the 2 most bottom ones, which means these 2. Ah, I see. Also delete all of these things, they're not necessary.
Bottom make it's no way impossible. Mhm.
How's it done? Good, just 5 more minutes already. I'm gonna turn this, make it off temporarily, rotate you, face the camera, move away. Okay.
So make it.
Right, we need like a make it actually, you know, nerd emoji kind of pose. Difficult.
Are you gonna do like the fucking glasses and shit thing?
No.
Oh.
There we go. It's with alpha already. Beautiful. Absolutely beautiful. Splendid, beautiful, amazing. I saved it without alpha. Of course I did. Going to be PNG with alpha.
So make it. This make it. This doesn't make any sense.
I should also switch up right here the default file from video to PNG with alpha, just make this easier, and then next frame will have to be make it thinking. Yeah, it's not how thumbs work. It's like a voodoo doll. I sometimes can feel it when it's moved around, you know. I need to be a bit careful with this. Okay, splendid. Save as one. Beautiful.
How can our particle move through an impassable barrier?
Okay, then this one will be kind of like looking into the camera. Head. Generally a bit more movement. Right. Splendid, render image. I really do like the extra spice with the timer in the corner. Makes it a bit more challenging.
Any sense? How can our particle move through an impassable barrier? This would be teleportation. You must have gotten it. Teleportation. You.
I really want like an bit at the end. We'll see if I can do it, but I could apply the post transform to all of the meshes, join them together, and I could use them as for physics. Oh shit, I did it in the same frame. I could use them for physics to do a fire simulation of the make. You'll see what I mean in a second. The hand looks a bit off, but eh, fixing it.
Move through an impassable barrier. This would be teleportation. You must have.
Then right here we can have like ever so slightly bent forwards. Splendid. Well, we don't have a theory to explain why charge exists yet. Comparing number one is shallow. We don't know is valid. It's not we don't know. Like our theory models them as elementary. That's why they are elementary. It's not shallow. It's just what it is. Yeah, let me show you. Fundamental interactions. Forces and interactions appear not to be reducible to more basic interactions. Da-da-da. You cannot reduce them. What's more, even funnier, is that you can like merge them even more if you want. You don't even need 4. You can have 2 if you're going crazy, or 3 if you're, well, just doing physics.
This would be teleportation. You must have gotten it wrong. But
Right, we need the second make it to the other side. Which is why I kicked it. Also, the other error sound was this animation finishing, which means I need to set up the next one. And this will go to 5700. I mean 5700. Beautiful. Move the keyframes. Like, what's the title of this video? I think it's going to be from addition to mechanics, but I don't know exactly. Something like that. Actually, I have to like make it responding like this. I love the animatronic pose when it's just not moving. Looks like a puppet just run out of battery. Things will be fine. Unless the fingers aren't even overlapping, even though I didn't see it. Good. I got lucky. Splendid. 5. Beautiful.
But no. No. To
There we go. Six.
no. To everything you just thought.
I do really feel like this has to end on something a tad more drastic, and the only thing I can think of is setting this make it on fire. Which I do believe this object apply. Was it all transforms? It might have been all transforms. Now if I do Alt P and then nah shit, obviously not. From this time. You didn't apply. There we go. Now that they're all applied, I can do Control J, delete the underlying thing, and I can. This is dumb but funny. Whatever. Quick effect, quick smoke. Haven't done fire in quite some time, but I hope that I still remember how to do it, because I'm pretty certain it is just U and then inflow, right? Because inflow meant into our scene. Or we can just do geometry. Can geometry be sustained as fire though? I don't remember. All from 5 to 70. Make all real quick. Yeah, it can be. Good. Oh no, it can't be. Alright, no, then we need inflow. That makes sense actually, kind of. The retrospect, it does make a lot of sense. This. Yup, splendid, free all. And let's now add some noise. Add dissolve, usually after 5 is fine. And up this to 128, I do believe was usually the extreme. Okay, it's gonna take a second to bake. Then we'll need to tweak the... Oh, my PC just got real loud right now. Oh my goodness. Well, can't blame you for it. I bought the entire CPU and GPU, and I'm gonna use the entire CPU and GPU, alright? The worst part would be if I, to be fair, it's just meant to be a little bit, I'll be on the screen for a couple of seconds, so. If it won't look perfect, I won't mind, I'll still probably leave it. I just hope that the shader of the underlying mesh won't change. Will it? It doesn't really appear like it will, let's see. Yep, splendid. Now all we need to do is just change the shader. That's because the way that this simulation basically works is we have volume info right here, and because we did fire and smoke, we have access to the temperature. What does flame do actually? Is that just the one that selects where flame is? Oh, I always prefer temperature, just a bit nicer. And then we're going to like a cutoff, then math, multiply by 3, and the reason why I want to multiply by 3 is because then if you increase the density to like 100, it just makes it way more pronounced. And then you can just do another color ramp, but this time for actual color. I know scandalous using the color map for color, but the reason why is because then you can... Right, I already forgot. This is not normalized. Absolutely beautiful. Well, I think that's fine. Especially if we add some motion blur or other stuff like these. Okay, how many frames do I have? Because I don't really fancy rendering, over-rendering this. 1, 2... That would be like 40, I think. I think 40 will be more than fine. Which means 45. And then we render it into a specific place, which is... fire. Sick. And done and dusted. Anything else? 32 samples. Hope it's gonna be enough. Render animation. It should render with alpha because we did switch to a PNG. And okay, that's a bit... Maybe not. Maybe let's move past the first frame. Also, motion blur, I did I didn't check. There we go. It's on the center of the frame. It should be started frame. Render animation. Just instead of being set on fire, just instantly turns into fire. Yeah, once the first couple of frames pass, this should look a fair bit better. Because like the smoke will go up a bit. Worst case scenario is gonna be fire, which I'm fine with whatever.
Yeah.
You
Genesis
see, our particle
oxidize every atom in his body.
isn't moving through our impassable wall, nor is it teleporting. It's time. You see, our particle isn't moving through our
Yeah. This.
isn't moving through our impassable wall, nor is it teleporting. It is
No, this is in fact wrong because what we want is we want.
nor is it teleporting. It is merely just existing through it. I can explain. This
Alright, splendid. My music. Switch to Discord sound. Right here, the video. I'm just gonna add the from the script. Direct consequence. Okay, there we go. It is direct consequence of quantum mechanics. That is correct. Quantum tunneling is kind of to say explained by quantum mechanics is a bit of an understatement. Like if you just follow quantum mechanics, you get to quantum tunneling. It is impossible in classical mechanics because obviously. Which is the least enjoyable part of the video making process? That's a good question. That's a good question. I would say it doesn't really matter as long as there's a part that I just need to make. Like for example, right now I'm not really enjoying the video making process because I can't just because I need to finish the video in 3 hours, right? And so, if I need to take a break, then, well, I can just piss off and and that's it, because, well, the video has to be done. Normally I don't mind animation. I would say the practical part is definitely the best one. I like the practical part the most. Whenever I'm working on a practical project on the video, that is the most enjoyable because, well, you're actually making something. So I would say video making is the least enjoyable part of video making. Actually happens. Which is why the theoretical videos I just like a bit less to make. This is the right thing, make it. Then the video. 5 more minutes. No, I just need 5 more minutes, trust me. I just need like 5 more minutes and it's gonna be finished. That's all I need. I need like 5 more minutes tops and then the video is gonna be finished. That's it. Just 5 minutes. Alright? Just 5 minutes. 5 more minutes and... And right here what would be best would probably for me to cut the segment out of that video where the quantum tunneling actually appeared. Which is a bit of a good question. Where was it? Oh no, I need... I'm hungry. Whatever, I'll suffer it out. There's a video to be done. Anyone remember what folder I saved the flame video in? Oh yeah, obviously fire chemistry. I was doing it with flame. It's just did this over there.
Your name combination is impeccable.
Yeah, I'm consistent. I'm consistent. Oh, where should I save the full? Finished question mark. That's apparently the name of the full video file. Because I was not, in fact, confident that it was in fact finished. The segment that included quantum tunneling was, I do believe, this. Well, the part where the spheres would kind of have a different distribution. There. I do believe this would be. No, because quantum, yeah. So this is quantum tunneling. Yeah. Somewhere, so that's because otherwise it's just too jarring all the transition. There, calling it fine. Leave the music. I know you can't hear. Y'all can't hear this because I disabled my desktop audio, but the music is a bit loud. -3. Okay, we're doing 16 minutes out of 30 something. Great, splendid. Can you make everybody go about the quantum tunnel for next video? that's how I jump actually. Okay, we're so close. I can feel my PC running slower. I know you all probably can't see it, but I can feel it. Just make it exploding in Animaker. That's probably what's dragging me down. This would be the opposite rotation. Are you a physicist? I don't know if you have mentioned before. No, I'm not a physicist actually. Funny enough. I just play one on TV. I'm not a chemist, I'm not a mathematician, I'm none of those things. I just I just do chemistry, physics, and mathematics. There we go, chemistry. Okay. We're not that far off. This one, oh, now it takes 2 minutes per frame because I'm also rendering the blowing up of a macon in the background. Animations wise, we have only 3 hours left. Splendid. Animations wise, we are right here. This is where we are, which means we still need to animate all of this. We are on page 9 out of 14. And we just need to go through your 14. It's simple. It's simple. It's simple. Okay. Hello everyone, I will be right back with you. Just give me a second. It's just skipping. We've been in the Blender file, we've actually been putting all of it on a line, going from mathematics to chemistry. I could have done it in a circle, then the colors would much been nicer. Ah, pointless. There, no, the entire video into the garbage. Really, no, it's not worth it anymore. I messed up. We're starting from scratch. Okay. Time we'll go. Yeah, exactly. We're starting over. Usually people with scientific papers more than their family have a professional academic connection in science. I find it pretty cool to be dedicated just because I really like science. I'm a science cultist. I believe that science is the best way to achieve the most correct answers most of the time. And that kind of makes me obsessed, yes. Let me switch to main desktop music again. I like the idea of lo-fi being for the last chapter. I don't know if it will fit in with the big revelation that electrons, particles. I want to get back to jazz. There's also dance groove. there's this race car driver named Canada, which is conveniently a swear word of my country. Conveniently.
This doesn't really make sense, but with the context it does, because when we're
No, someone's banging on my pipes again. Splendid.
referring to particle as a point, we mean the particle. If we're referring to particle as a shape, then we're talking about the probability of us finding it somewhere. And so with that context in mind, we can simplify our function back into a sphere. And finally, move on to...
This should be the...
chemistry. And so now, in order to fully move on to chemistry. And so now...
Why is there an echo? There was no...
Now, in order to fully transition from quantum mechanics to chemistry, we need to take our particle with an arbitrary function and change it into an electron. Chemistry. And so now, in order to
right here, I've said those loops.
finally move on to...
except we don't have loop for the first thing. Oh yeah, right, because there is no particle first.
Finally, move on to chemistry. And so now, in order to
It's a bit loud and stream. I'm so sorry for that.
fully transition from quantum mechanics to chemistry, we need to take our particle with an arbitrary function and change it with an arbitrary function and change it into an electron in it into an
Oh yeah, this was the loop. I'm an idiot.
with an arbitrary function and change it.
No, this isn't a loop. I just don't have a loop for this. That's not great at all. I can cheese this, I suppose, but...
and change it into an
This one I can cheese. I can cheese this by... can I cheese this? I didn't do a loop, did I?
and change it into an electron and change it into an electron in the 1s in the 1s orbital.
Oh, there's so much left. How does there seem to be more every single time I look at it? I apologize in advance for questioning you, but what's the point of time on the screen if it only works when you interact with it? Did the timer stop again? No, it does count down. It's just that sometimes OBS just stops capturing it. I don't know why. Well, I do know why. I know the cause. I just don't know why the cause happens. You get what you don't get what I mean. It doesn't matter. It's irrelevant because what we're actually doing.
That's it.
Is this?
Yeah, electrons.
And believe it or not, these
That's
are actually... We did actually right now just run out of animations. Because if I scroll down, then... This right here. Oh, piss off. Can I link media to it? I can. Beautiful.
Yeah, electrons and electron orbitals are precisely what we've talked about so far. Electrons are the particles, and orbitals are just the possible wave.
Oh no, wait, this has to be the loop.
Electrons and electron orbitals are precisely what we've talked about so far. Electrons are the particles, and orbitals are just the possible wave functions. That's what. Just the possible wave. Electrons are the particles. Yeah, electrons and electron orbitals are precisely what.
Ah, shit. We might need to...
Yeah, electrons and electron orbitals are precisely it. Yeah, electrons and electron orbitals are precisely what we've talked about.
I don't like doing this, but I think the best course of action for me would be to stop the stream. Because the main thing slowing me down right now will be the fact that the renders take a long time. Because I've run out of animations. For the entire rest of the video, for all of this, I've got no animations, I need to make all of them. And the fact that I'm streaming is probably significantly slowing it down. Yeah. Well,
That's sad. Is it over then?
it's not the first time this happened. It's not the first time I'm doing 5-minute stream and I'm ending it like this. That's almost how almost all of the 5-minute streams end, with me just not being able to stream because it's affecting the speed at which I'm finishing the video. But this is all that is left. It's going to be shorter than it seems because, well, I did mess up the lines a lot. And on the left, everything on the left is what's already finished. Everything on the right is what's still left to do. Which is actually a lot more than I expected, but... oh well. Anyway, that's it for now. I need to... I need to stop the stream because that will speed it up. And for now, that'll be it. Thank you everyone. Fuck, I'm so exhausted. And for now, that'll be it. Thank you everyone so much for watching and have a great day. Bye.